Tornadoes are among the most powerful and unpredictable forces in nature. In just a few minutes, they can turn a calm afternoon into chaos, tearing through towns with winds strong enough to lift cars and uproot trees. But how do these swirling giants actually form? Let's explore the science behind tornadoes. Everything begins with a thunderstorm, specifically a type called a supercell. A supercell is a large, rotating storm that can stretch miles into the sky. Inside it, warm, moist air from the ground rises and meets cool, dry air from above. This mix of temperatures and wind speeds creates instability, the perfect condition for something dramatic to happen. As warm air rises and cool air sinks, winds at different altitudes begin blowing at different speeds and directions. This difference in wind speed creates a horizontal spinning effect in the lower atmosphere, almost like an invisible rolling tube of air. Normally, this invisible rotation stays harmless. But inside a supercell, powerful updrafts of warm air can tilt that horizontal spin into a vertical one. Now the storm itself starts to rotate, and that's when things get dangerous. Once this rotation tightens and speeds up near the base of the cloud, a funneled shape begins to form. This rotating column of air, known as a mesocyclone, stretches downward. If it reaches the ground, it becomes a tornado. The funnel cloud picks up dust and debris, making it visible as it touches down and begins to move. The stronger the difference between warm, moist air and cold, dry air, the more intense the tornado can become. Most tornadoes last only a few minutes and travel a few kilometers. But the most powerful ones can last over an hour and stretch more than a mile wide. Wind speeds inside the most extreme tornadoes can exceed for 180 kilometers per hour. Scientists measure their strength using the enhanced Fujita scale, or EF scale, which ranges from EF0 for weaker tornadoes to EF5 for catastrophic ones that can flatten entire neighborhoods. Tornadoes can form almost anywhere if the conditions are right. But they are most common in a region of the United States known as Tornado Alley. This area, stretching across parts of Texas, Oklahoma, Kansas, and Nebraska, regularly sees warm air from the Gulf of Mexico colliding with cold, dry air from Canada. That contrast fuels the perfect storm for tornado formation. However, tornadoes also occur in many other countries, including Canada, Argentina, Bangladesh, and Australia. Scientists use radar technology and storm-chasing teams to study tornadoes up close. Doppler radar helps meteorologists detect rotation inside storms before a tornado even forms, allowing them to issue early warnings that save lives. Still, predicting exactly where and when a tornado will touch down remains one of the toughest challenges. In weather science, if you ever see a dark, rotating cloud or hear sirens warning of a tornado, it is vital to seek shelter immediately, ideally in a basement or an interior room without windows. These few minutes of safety can make all the difference. Tornadoes may be terrifying, but they are also a fascinating example of nature's power and complexity, formed by wind, temperature, and rotation working together in perfect, stormy harmony. If you enjoy learning how nature's most powerful phenomena work, make sure to subscribe to my channel How Things Work and comment the next topic you want to learn.